Hello, let's continue the first chapter of mathematical interest theory. Let's talk about present value and discount rate. The present value is a very important concept in theory of interest. It gives us a way of comparing uh, two cash flows or comparing value of the money at different times. Okay, so for example, $100 in 1 year versus $200 in 2 years, which one is better? So you need to look at interest rate and calculate the sort of present value. So first concept, I want to introduce the cash flow. The cash flow is simply a series of deposit or withdrawals or payments made at different time. So oftentimes we draw a timeline, something like you draw a line, okay, and you put times. So that's zero, maybe T0, so T0, T1, and so forth, T sub n, or little n or capital N, doesn't matter. Inflow is made to the individual and outflow made by the individual. It really depends on where you sit. Okay, the individual will be based on the bank or based on you if you borrow money from the bank. Um, so you can set one to be positive, the other to be negative. All right, so we can use a table to illustrate the cash flow. Uh, so here we have time in years T1, the investment C1, T2, C2, CN, TN. Okay, so CIs might be negative, maybe negative. Okay, so how to compare two cash flows? Here an example. You have two options. One, you get $400 now. Second, you get $100 each year for 5 years. Which one's better for you? And so we actually need to figure out the present value of the cash flow of $100 each year for 5 years. So 5 years, right? 100. So totally you would get $500. Right? You only get $400 now, but it really depends on the interest rate. So you needed to look at the accumulation function, and then you calculate the present value. So how can we do that? Let me let me work on this problem a little bit more. Say, let's use the compound interest. Let's use simple interest. Compound interest, I need to calculate a little bit more. So you have A of t equals uh, A of 0 times 1 plus R times t, okay? And let's put draw a timeline. So you have 5 years, right? I mean, the first one's pretty clear. You have $400 now, so you have 0, uh, 1, 2, 3, 4, 5. And you will get $100 on each year for 5 years. And one way of doing that is calculate the uh, present value of each, and you add them up. So you would get 100 divided by um, 1 plus R, which is 1 year, and then you have 100 divided by 1 plus 2R plus 100 plus 3R. Okay. And let's say R equals 0.05. Then you calculate this value and you compare with 400. If this value is bigger than 400, then I would claim that the second option is better. Okay, if it's smaller than 400, then the the first option is better. And obviously, the value depends on R, so you make R bigger than the present value is normally smaller. Okay, so it really depends. Similar to the interest rate, we're gonna introduce the concept of discount rate. So first of all, we have effective discount rate. D sub T1, T2 equals 82 minus 81 divided by 82. So I want you to recall the effective interest rate from T1 to T2. That is, the numerator is the same, and the denominator is different. For interest, the denominator is 81, but for discount rate is 82. Similarly, for periodic times, and you have say 1, 2, 3, 4. They have the same length. Then D sub n is defined by a of n minus a of n minus 1 divided by a of n. This is more general than this one. This is only when it's a special case of this when the time periods are having the same length. These two values are called equivalent if they correspond to the same accumulation function. So you have the same time growth scheme. Okay. Then we can calculate one from the other. Here's an important fact about these two effect rates. 1 plus I effective rate of interest times 1 minus the effective discount rate equals 1. Okay. I have to emphasize that this is effective rate. Both are effective rates, and this is very important. Later on, when we talk about nominal rate, it gets very confusing. All right, so this is it's a very general formula. We define discount function as 1 over the accumulation function. Okay, so suppose you have $1 here, and in 1 year, or actually 1 T years, you would have a of t, little a of t, so much money. That's a cumulative value when the principal is $1. What does discount function tells us is if you have $1 here at time t, then equivalently you have a v of t dollars at time 0. So v of t, you multiply, if you treat it as the principal and you multiply by a of t, accumulating it, right? So this is accumulating and this is discounting. Well, I mean, both ways. Not necessarily. This is also accumulating. This is discounting. This is also discount. So VT times AT equals 1, right? You treat this as the principal and accumulate it at time t using A of t, you would get $1. Okay? Uh, Now this picture is also kind of important. So how to calculate the cash flow? So here we have the table of cash flow, time T1, T2, T sub n, and then you have C1, C2, C sub n. So the net present value, NPV, is equal to the summation of the present value of each, whether it's investment or here we're talking about investment, so it's the investments. Okay. And this is the discount function. What we're doing here is, say T0 is here, so this is T0, okay? And then you discount back, and then you add them up. Okay, that's what it says. Okay, so we have this accumulation function. A of t equals 1.03 to the 2t. How much does one need to invest to accumulate $10,000 at time 3? So we have capital A of 3 equals $10,000. This is the amount. That equals A of 0, which I think we're looking for, the principal, times 1.03 to the 2 times 3, which is 6. All right, so that's not very easy, not very difficult to find. So A of 0 equals 10,000 divided by 1.03 to the 6. All right. Peter invests $738 in a bank account. 1 year later, his bank account has so much money. Find I1 and find D1. So I1 equals A2 minus A1 minus A0 here. So it's 765 minus 738. That divided by 3, 738. And D1, it's 1 year. Still do having the same numerator, but divided by 765. So generally, interest rate is always bigger than the discount rate. Okay. Let's introduce the concept of interest factor. So suppose you have A of n, which assuming the time periods are the same, having the same length. So nth year interest fact, okay, nth year interest fact is from n minus 1th year to nth year. The interest fact is A of n divided by A of n minus 1. And the discount factor is you flip it. Okay. And the effective interest rate, we actually talked about that. And this effective discount rate is also we talked about that. The only difference is the denominator. Okay. The interest factor is basically saying that you have A of n minus 1 at time n minus 1, and you multiply by the interest factor, you would get the amount at n. Yeah, that's basically what it means. So this is interest factor. This is the money you have at time n minus 1. This is the money you have at time n. Uh, let's see. I wanted to, yeah, maybe I should say a little bit more here in the previous. We have interest rate IN. So the interest factor is actually 1 plus I sub n. That's the interest factor at the nth year. Okay. All right. Uh, I think you can see very clearly from here. Uh, you break it up, you get a of n divided by a of n minus 1. Okay. And you move one to the left side, you get to the factor, which is 1 plus the interest rate. And the discount factor is 1 minus the discount rate. All right. So if you have $1 here, and you're going to multiply by 1 minus dn, and you would get the money here. All right. And if you accumulate it, you would get $1 is 1 minus dn times 1 plus in. So this is the uh, the interest factor. This is discount factor. So the product of these two is 1. These two formulas are it's relatively easy to find, but it's good for you to memorize them because sometimes you, especially you want to take the exam for societal actuary, you want to be faster, and then these formulas are, if you remember them, then it's pretty easy to work. Okay. Uh, so algebraically, they're pretty easy to prove. But then also you wanted to sort of see it, try to understand it from theoretically instead of just algebraically finding it using using this equation. Okay. So basically, if you have dn here, and then you accumulate, you would get in. Okay, that's basically what it says. All right, so d sub n times 1 plus in, you would get I sub n. And I sub n, you do discount, multiply by the discount factor, you would get d of d sub n. Okay, so that's this picture probably is also kind of interesting, and you should understand it. Under compound interest, the normal case, right? The normal case. And we will show later on that the well, I don't want to say that. The effect rate will be the same. Uh, I was thinking about force of interest, but that's towards the end of the chapter. So the fact is that the effect rate is the same along the time. So that's why we have little v, little I. They are sort of constants, not I sub n or I sub t. Okay. So for compound interest, uh, the discount factor is denoted by v. Okay. And that equals 1 over 1 plus I. Basically, again, you have a $1 here and a 0, 1. So you have $1 here and you will have a v here. Okay. And if you have a I here, then you have a B here. Okay. So discount factor is V, which is 1 minus D. Okay. Um, and the key formula is still this. Okay, it's still this. 1 plus the effective rate, effective interest rate times 1 minus the effective discount rate is 1. And 1 plus I is the interest factor, and 1 minus D is discount factor. So you multiply amount by the interest factor, you will get the amount. If you multiply some value later on by the discount factor, you will get the value right now. Okay. All right, so V of t is the discount function, which is 1 plus I to the negative t. Again, this is for compound interest, okay? It's very important to emphasize that. For simple interest, you don't have that. You have a different discount function. And A of t equals V of negative t, V to the negative t. Uh, there are a lot of formulas. You try to sort of learn the principles, then it is easier to understand. So you don't have to memorize without understanding. It's more complicated. And I think we explained a little bit more, a little bit earlier. So suppose you need to borrow some money instead of, so this is usually what the bank would do when they apply discount. So you need to borrow some money instead of sending you that amount. The lender charges interest before the money is released. That part of money is D if $1 is borrowed. So right now you borrow 1 minus D now instead of $1. That's the normal case. You want $1 and you pay 1 plus I later. Instead of that, you borrow 1 minus D now and pay $1 back after 1 year. All right, let's work with those formulas. Uh, for the moment, we're working with effective rates, so it should be okay. So find D, right? D, we have 1 plus I times 1 minus D equals 1. And so D equals what? D equals 1 plus 1 minus 1 over 1 plus I, so which is I over 1 plus I. Okay. So that equals 0.07 over 1.07. 1 plus I is 1.07. So that's that. And V is 1 minus V is 1 over 1 plus I. Okay. V equals 1 over 1 plus I. That's 1 over 1.07. Okay. Let's see. Let's draw this thing again. So you have D here, you have I here. Okay. So D would equal to I times the uh, discount factor, which is V. Okay. So V also equals D over I. That also equals 0.06542 over 0.07. Okay. Yeah, I think so. All right. So they are sort of simply using the formulas or relations. Okay. Now we have V and looking for D and I. So V is 1 over 1 plus I. So V is 1 over 1 plus I. It's the discount factor. So I would be equal to 1 over V minus 1. So it's 1 over 0.95 minus 1. And D, how to find D? So 1 minus D equals uh, equals I. Sorry. This is D, this is I. So I times 1, I times D, V equals D. Okay. Uh, but I believe V is 1 minus D. It's D. So we do have that. We do have this relation. Okay. So D equals 1 minus V, which is 5%. All right, so next. What is the present value of $5,000 to be received in 7 years at an annual effective rate of discount of 7%? So this is little d, not little I. The present value, uh, we're looking for the present value. You have a $5,000. You have $5,000 to be received at time 7, 0, $5,000. We're looking for the present value here. So you have a discount rate given. So you need to discount back and annual effective rate of 7%. It's 1 minus D to the 7. Okay, that is PV. So another way to look at it is BV times 1 plus I to the 7. That equals 5,000. But 1 plus I times 1 minus D equals 1. And so when you divide this thing by 1 plus I to the 7, it's like you multiply by 1 minus D to the 7. Okay, so that's how you can get it. Um, I didn't, I think there's a different version of the slides. These answers wouldn't show, but for some reason, I think I'm using the old slides. Uh, the answers are shown right away. Okay, it's fine. So at time t equals 0, Paul invests $3,500 into an account with an annual discount factor. Discount factors 1 minus D of 0.76. Find the funded value at t equals 2.5. So actually you need to do so 1 plus I to the 2.5. That is what we are looking for. Okay. And you understand 1 plus I times 1 minus D equals 1, so that equals 3,500 times 1 minus d to the negative 2.5. So that is 3,500 times 1 minus d is the uh, discount factor 0.96 to the negative 2.5. Okay, so get that value. Uh, let's talk about simple discount. Simple discount, uh, it's actually yeah, it's not exactly you would get from simple interest. Okay, uh, for simple interest, you would have a of t equals where to get that one from? It's a one. It's a one plus it. I is the annual rate. It's linear, so that's the key. It's the linear. It's linear. So the discount function is 1 over a of t. That is not a simple discount function. So for a simple discount function, we assume the discount function to be 1 minus dt is linear. Okay, this is linear again. So simple discount function is linear. And if you use the simple discount function for the accumulation function, and that simple, the accumulation function is not simple anymore. Okay, it's not a simple accumulation function. So this is something I want you to be aware of. So simple discount is the discount function being linear. Okay. It's not coming from the simple accumulation function. It doesn't come from there. Right. I don't have any example for this one. Okay, so I think, sorry. Mm. I think I'm going to stop here. I wanted to start anew for the next topic, which is nominal rate. Uh, it has a lot of things. Yeah, uh, I think bye for now.